Hey guys, today we are going to do instruct tuning or supervised fine-tuning, which is SFT, on TinyLlama to create ChatGPT-like applications. In this specific case, I'm going to use TinyLlama, but you can use Llama 2 either. They have the same architecture, so it is welcome. This fine-tuning is the first step to create ChatGPT-like applications or chatbots, and it is a very crucial step to understand and to be able to implement. And let's look at the schedule. So in the end, we will have results like this. We will ask who is Napoleon Bonaparte to the model, and the model will answer us, just like you can see here. Or we will give a model set of choices that it can choose from. For example, we will ask what is the capital of Spain, and we will give a predefined set of cities to choose from, and the model will make the correct choice for us. Furthermore, we will do some small talks with the model, such as we will ask the model what its favorite color is. And I will also explain the different data formats and when to use which one. For example, there is one with 3 hashtags and says instruction. There is a one which starts inst and many other data formats. It can be pretty confusing on when to use which one. Some say it doesn't matter which format you follow, some say it matters and even give a specific instructions on how to follow. I will explain to you why do they say that and when to use which approach. Furthermore, I will show you how you can load your own data from your local machine and do the training with that instead of using ready-to-use datasets from the internet. Before we begin, make sure you subscribe to my channel, like the video, what you want to see next, comment it out. Those out of the way, let's just get into it. So right now, as you can see, we are in my Collab notebook. By the way, you can use whatever notebook you want as long as it runs the code. Let's start by installing the necessary libraries. We will need Accelerate, we will need Path, we will need BitsAndBytes, we will need Transformers, and we will need CHRL. And let's run this. Now the installation is complete, we can move to the importing libraries. By the way, in the end, it may say like dependency resolver, like the incompatible packages. It's fine, okay? Don't worry about it. Now let's start by importing the necessary libraries. First we will need operating system OS. After that we will do something like OS environment transformers no advisory warnings to true. So this will suppress some unnecessary warnings for us, so we will have a cleaner progression. After that we will need torch, we will need random, we will need NumPy, we import that too, we will need datasets and we will need load dataset. That is how we will load our datasets. We need Llama tokenizer fast to tokenize the text. We will need Llama for casual language model. This is will be our main model object. We will need BitsAndBytes complex so that we can quantize our model. We will need training arguments and we will need pipeline. We will use the pipeline for inferencing. Next, we will use LoRA, so we will import LoRA config from the path library. And at last, from CHRL, we will import SFT trainer, which is the trainer that we are going to use for our main training. And when they're all done, we can just run the cell. Now we are going to continue with defining the hyperparameters. We are going to start with our base model. This is the model we are going to load. So I decided to use TinyLlama because it is small and it can fit into GPU and your memory much easier. And it's just overall faster to train. So we are going to use TinyLlama and we are going to use this version of TinyLlama. So what this version means is that while training a language model, there are several time steps. Okay. If we go into the TinyLlama's GitHub page, we can see several checkpoints and they are from newest to the oldest. Alright, so we are going to, what we are using is this one, this version over here. So it is actually the newest checkpoint of the TinyLlama. And we will load it from this Huggingface's model card over here. As you can see, this is what we are going to use. This is currently the latest one, but whenever you watch it, don't hesitate to use different checkpoints. One thing to note here is that I will mention a bit about that later, but we are going to use the checkpoint for the language model, not the chat model, okay? It means that these chat models are already trained on a chat data, like we are going to train now, but these language models are just pure language models, okay? We are just going to train them from the beginning, and depending on which one you are going to choose and which of the model will you follow, like the pure language model or the chat model, there are some differences, okay? I will explain them a little bit later, but for now, just know that we are using the language model one, pure language model one, or base language model one. Another thing to note here is that with TinyLlama, it is the same architecture and same tokenizer as Llama 2. So what I'm doing here is that you can use it with, you can do the same things with Llama 2, okay? The only difference will be this model name. That out of the way, we will need dataset name. We are going to use the Alpaca dataset, which is here in the datasets. So I will talk a bit about that and the difference between the datasets and how to prepare different datasets and your own datasets a little bit later. But for now, know that we will use this format, okay? I will explain the different formats between different datasets, which I believe is very confusing, okay? But I will teach you all of them. So after we write down our dataset name, we will continue with random seed. This will use to make our code reproducible. We will need batch size. So I set the batch size to, okay, because that's how much I could fit into my memory. Now it is time for epochs. To do that, to decide how many epochs we need, let's just actually go to the paper, Llama 2 paper, like we showed here. The TinyLlama uses the same model architecture and everything with Llama 2. So we will base the Llama 2 paper for our hyperparameters. So let's search for epochs, and as we can see, fine-tuning, they used 2 epochs. So we will directly copy that from the paper. Now it's time for learning rate. The learning rate they used is 2e-5, as we can see here. So we are going to just copy that learning rate. We will need a learning rate scheduler. So again, let's go to the paper. By the way, we have some parameters in the fine-tuning details, which is what we are doing. We are fine-tuning, but I will take some of them from the original training site, which is here. Okay, this is the training of the language model, but even though it is that, I find them to be sufficient when they are used for fine-tuning too. So some of them I will copy them from the training details, which is not actually what we are doing, but they work fine. And the rest is I will copy from the fine-tuning details part. All right, so with that in mind, we can just continue. And we can see here that they used cosine learning rate schedule. So we just copy that to say cosine. Optimizer, they mentioned they used AdamV, which is here, AdamV optimizer. So we will not just use directly AdamV, but paged AdamV 32 bits. Okay, you can use AdamV too if you want, but I'm gonna choose this. After that, we will need beta 1 and 2 values for our optimizer. So let's go over here. We can see beta 1 is 0.9 and beta 2 is 0.95. After that, we need epsilon again for our AdamV. For that epsilon, we can just look at here and we can see epsilon is 10 to the minus 5. We copy that directly to here. Now the warm-up steps, again, let's look at the paper and say just warm-up steps. They use 2000 warm-up steps. So we are just going to copy that directly here. Warm-up steps equals to 2000. Logging steps, it depends to us. It just says that at every 1000 time steps, just log us the loss of the model. Okay, I find 1000 to be just decent for this use case. So leave it as 1000. Now we will need weight decay. Again, let's go to the paper and say weight decay, here it is. They used weight decay of 0.1. So we just copy that directly from the paper 2, weight decay is 0.1. Now the context length is originally 4096 tokens in the Llama 2, but I will use 2048 so that things will be a bit faster, and it just, for this example it is just fine. But if you wanna just stick to the original paper, I suggest you to use 4096. But for now we will continue with 2048. After that we will need FP16. This is a number format that will make the training a bit faster, so we will set it to true. Gradient clipping I set to 1 because when we come here, the gradient clipping is 1 in the paper. Okay, so I set the gradient clipping to 1, and we are done with defining hyperparameters. And what I suggest is just go and play with these hyperparameters, okay? Most of them we took from the fine-tuning part of the paper. Some of them we took from the training part, which is not what we are doing, but still these parameters works fine for my dataset and my model. However, depending on your dataset, I suggest you play with those, experiment different types of hyperparameters, give them different values and stuff like that. So these are not the grand truth, but they just work fine in my case. So let's continue with setting up the random seeds. Let's start by the random seed.seed, random seed, numpy.random seed. We have to set the torch manual, torch.qda manual.seed, because this libraries the trainers we are going to use are using PyTorch in the backend. So it is good to set them so that our code will be reproducible. Torch.another qda manual seed, backends qda and deterministic, qda and benchmark. These are the things that I do in my all videos. And after that we need our device, whether we are on GPU, so that it is qda, else if we are on CPU, it is CPU. Let's delete that too. And let's run the cell. Now let's continue with creating our tokenizer. We will use Llama tokenizer fast that we imported. We will say from pre-train, and we will give our base model. This will load a fast Llama tokenizer for us. However, there are a couple of things we need to do. First of all, initially this tokenizer doesn't have a pet token, so we have to give it a pet token. So you may see different approaches here. Okay, some people are making it equal with the end of the sequence token, which is EOS token. However, I think this is better, giving it a different token, because after all, pet token and end of the sequence token are not the same tokens or any other token. So instead of making it equal with a special token like that, I think it is a better practice to give it a all different token like a pet token over here. Another thing we need to do is we have to specify the padding site as right, because we want to pad to the end of the sequence. And also, if you don't specify it, you may encounter some errors depending on the depending on the quantization you are using. So these settings are fine, and let's just run the cell. So our tokenizer have loaded. You don't have to carry about these warnings, okay? So now let's continue with loading our dataset. So first I will show you to load it from the Huggingface's dataset, and then I will show you how you can create and load it from your local machine. Create a dataset and load it from your local machine, okay? If you want to load it from the Huggingface's datasets, okay, so like I mentioned, we are going to load these from Huggingface dataset. What you want to do is you create a dataset object and say load dataset. You give the dataset name and you give which split you want to take, whether it is train, validation, or test. In this case, we are taking the test, and by specifying this, I say that I just only want the 10% of the whole dataset. Why I do that? Because otherwise it takes a long time, and this is just a sample, okay? If you want to train it on your whole dataset, don't specify the 10%. And let's just print the length of the dataset and see how it looks like. Before moving on to see what's inside the dataset object and create our own dataset from our local machine, first let's see what is the data format. or what are the different data formats and which one should we follow. So this is one Alpaca dataset. Okay, the field we are going to look and we should look is the text, because this is what we are going to feed to our model. So the first thing we notice is there are 3 hashtags before instruction. Okay, 3 hashtags before response, and it goes like this. And in the beginning of all of them, there is a system prompt, says below is an instruction that describes a task, blah, 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 and it goes like that. So this is one popular format, and let's look at another one. Okay. And this one is different, okay? The task is the same, but if you look at it, let's see an English one. It starts with an S and it says inst, and it actually gives the instruction, and it then continues with the response. Okay, there are no 3 hashtags, or there are no system prompts, whatever. So which one to use, which format to follow? So answer to this depends on whether you are using a base language model or an already fine-tuned chat model. So if you are using a base model, like we are doing over here, it doesn't matter, because this is just a language model, alright? It just predicts the next token. So it doesn't care, and it doesn't know that you have 3 hashtags, or you have this inst here, or your first name. You can put whatever you want, okay? The only thing that it cares is that it learns this format throughout the training. It learns what you are trying to say with these symbols. So for this, we can use whatever we want. I will use 3 hashtags. This is the one case, okay? This is the case that we don't care. And there is actually another case. So let's say that you take an already trained language model on chat. Okay, so for example, this Llama 1.1b chat is already trained on a dataset, and it is capable of performing chat tasks. In this case, if you want to take this data and train on top of it, we have to be careful on which data we choose. Because, for example, here they inform us that they are following the ChatML format. So when we click to this ChatML and go to the website, this is not found, but it is this, okay? We can see that it follows such as I'm start, system, assistant, and it goes what is all about, and things like that. Or a better thing, here is the system prompt, and here is the user message, and here is the response. For example, this is the data format that is followed by chat. So if we take this model that is trained on this format, and if we train it on another data format like this, there will be a confusion for the model, okay? Because we have taught the model already in this TinyLlama case that it should follow this system prompt. And if we are using such a model that is already trained, we should stick with its format. That is one important point to take care. Like I mentioned, for this one, we are not going to be training an already fine-tuned chat model. We are going to use a language model from the beginning, this one, so we can choose whatever format we want. I will follow this 3 hashtag format. Another thing to note about data format is that, let's say there is this input field, okay? What is this? Sometimes it is empty, sometimes it is not. What this is that if we want to provide the context for our model, like we want to choose one of them, okay? We want to give the information to the model, and we want the model to answer according to that context. In that cases, we define an input field. For example, let's take this out. We want the model to identify the one out, okay? And which ones are going to identify. And we give the input field Twitter, Instagram, and Telegram, for example, okay, we want the model to identify the odd one out from this input section. In such cases, we add the input field to the overall text, like we can see here. Let's take a look. It should be about here. You see, there's this input field. That's what input field serves to. That's out of the way. Let's continue. Now let's print some parts of the dataset object. Let's start by printing the index 0 of the dataset and the text field of the index 0. Text field, we are going to use it to feed the model for training. And let's take another field, 6. This field will have the input side not empty, so it will have an additional input field. And let's see the text field of that too. Let's just print this. As you can see, it has instruction, which is what we want the model to do. Input field is empty for this one. And the output is the response from the model. And we have this characters. This means a new line. So when we are prompting the model, we will take note of these new lines, which we will discuss in the end when we are doing an inference. But just keep in mind that there are new line characters in the text field. And exercise regularly, blah, blah, blah. It goes all the way to the response, end of the response. Okay. And this is how the text field looks like. We have the instruction started with 3 hashtags. We have this new line here, okay, which we can see here. We discussed these new lines, okay. These are the new lines. New line here, and then give 3 tips for staying healthy. This is the input. Again, some new lines here, okay, and we have the response. This is the response we want. Another index. Now we have the instruction, just the same. We have the input in this case, okay. We give a task to the model and we say the following fraction is equal to 1 to the 4. And this is the following fraction, the input field. Again, we have the output as usual, and we have the text field. To the text field, we just add the input field, just in the same manner. So we can see here, we have the instruction, new line. By the way, I skipped it, but we have also a system prompt here. Okay, this system prompt is a good to add to model to understand what to do. First, we have the system prompt. As usual, new line, we have the instruction with 3 hashtags, and we have the instruction over here. Additionally, this time we have the input, and after that we have the response that we want the model to give. So we can verify that our dataset object has loaded correctly. Now it's time to show how we can prepare our own dataset and load it to here and work with it. Okay, so I prepared a dummy one for us. So look at this JSON file. This is the minimal thing you can have. It is a simple JSON file with only a text field. We are going to use only the text field anyways. And this is our 2 examples that we dealt with just previously. This is the system prompt. This is the instruction. And it goes like this. This is the whole same text field. Okay, this is for demonstration, like I said, dummy data, but this is one of the ways your local data can look like. You can prepare it to look like. Now I took the data and uploaded to my Google Drive since I'm using Colab. And here, just the same way I loaded my data here with the load, I said load dataset. I give the file type of my file, which like we mentioned and showed is a JSON file. And we say data files and give the path to my file, which is dummydata.json, and here is the full path in my case. It is a different path in your case, okay? And it automatically creates a train split. So I just say train here, or you can do it like split train probably. You can try, but this just works. For different data types, you can come here and check this website, okay? This is why I took it anyways. So this is Hugging Face datasets inside load. It shows you how to load CSV, JSON, what we used here, paraquet, arrow, and whatever, It is just a simple thing to do. No big deal. We load it and let's see if actually it works correctly. We loaded that and let's print the length of it. We expect 2 because we only have 2 examples in it. And yes, the length is correct. We only have 2 input fields, so the length is 2. Let's print those fields now. First, let's print the first field, which is the 0th index. And let's print the second field, which is the first index. Just the way we want. The text is this inside the text field, and the other one is this with the input field. As you can see, this is exactly in the same format as the previous one, and this is how you load and prepare data for your own use case. Now we load our data. However, before moving on, there is one last step that I want to make, which is to add an end of the sequence token to the text. What it is that it's a special token that says when it is generated, the model knows it shouldn't generate anymore. So it denotes the end of the sequence. How we are going to do that is we just create a new function called add EOS token. EOS stands for end of the sequence, and we will give an input as an argument. Then we will take the text field and we will add the end of the sequence special token from Tokenizer. Since it is a special token, we can just say Tokenizer that EOS token to access that, and we just return the input. We update the dataset by creating a new dataset called updated datasets and use the map function and give out the add EOS token, which is our function, as the argument. This map just takes every element and gives this to this function as input and applies this process to every element in that. After mapping is complete, let's just print the 0th index again and let's see that if the changes are really made. So let's run the cell and here is the output. So again, we have the system prompt, we have the instruction response, but in the end there is this end of the sequence token, so it works fine. Now we are done with the dataset. So congratulations, I guess. I think that is one of the toughest parts about dealing with any deep learning problem, is preparing the data, making it correct format and understanding it. So to continue, we will actually now start loading and configuring our model. The first thing we are going to do is we will quantize our model. So we will define a config file for that. We will use BitsAndBytes config that we imported in the beginning. So we will do quantization in 4-bit. So we will say load and 4-bit equals the true. BNB 4-bit quant type, we will give it NF4. And for the 4-bit compute D type, we will give it torch bfloat 16. As last, we will say BNB 4-bit use double quant equals true. What it does is it quantizes the model 2 times. Okay, something like that, before and after load. Something similar, but it's a good thing, okay. And after that, we just close the brackets and run this. Now we load our model. Just how we do it, model equals the Llama for casual LM. What we are doing is casual language modeling. We say from pre-trained, we give the base model, which is path to where the model we are loading. Just the difference from regular model loadings is that we say quantization config equals the quant config. So this quantization is important because if you don't do that, it will take time to make the trainings. Now the model is loaded. Another thing we are going to use to be more memory sufficient and faster training is LoRA. Okay, so we will configure LoRA now. How we are going to do that is we will say LoRA config. We will say R64, LoRA alpha 32, dropout 0.05, bias is none, task type casual LM, what the task we are doing, and that's it. So these settings worked fine in my case. By the way, I won't explain what they are, but because it is out of the scope, I think. But you can just go to the Huggingface's path library and check the LoRA config and experiment with different settings. Let's run this. It's time to define the training arguments, the training parameters. So we just say training parameters equals the training arguments, and we start to give our arguments. We will need an output directory, so I won't use this model again, so I said in delete me. But if you want to save your checkpoints and your outputs, you can give an output directory of your choice. We have number of training epochs we defined in the beginning as epochs. We have per device trained batch size. Again, this is the hyperparameter batch size. We have the optim, which is the optimizer. We defined it as a string in the beginning. It just takes the string and loads the optimizer for us. We have the logging steps, in how many iterations it will do the logging of the loss and related things for us. We have the learning rate defined. We have the weight decay defined. We have the FP16, which is a data type, something like half precision floating something. And what it does is that with this, we use less memory and we do the training faster. So there are a couple of options, FP16, BF16, if I'm not wrong. Depending on your GPU, it may be available or not be available. So if you get an error, just try to set it to true, set it to false, and play with it, okay? After that, we have warm-up steps set, learning rate scheduler set. We have the ADAM numbers, ADAM beta 1, beta 2, and the epsilon. We have the gradient normalization, which is a gradient clipping that is set to, and we are done with our training arguments. Now we will define the actual trainer. We will use SFT trainer from the Huggingface. So this SFT trainer actually builds on the regular Huggingface trainer, and we are going to use that. So we say model equals to model. We give our training dataset equals to dataset. And the dataset text field, which is as name suggests, the text field of the dataset, and we define it as text. If it is a different field in your dataset, just type its name, okay, it doesn't matter. We have the path config, which we did with LoRA, configured the LoRA. After that, we give our tokenizer, which is tokenizer. As args, we give our training parameters. Max sequence length, we defined our max sequence length as hyperparameter in the beginning. We give that, and that is all. To start the actual training, what we do is we say trainer.train and run the cell. So the training has started. When it is done, let's meet here again to do some inference and see how our results will look like. Now, as you can see, our training is complete. Let's look at the results. As you can see, we have the loss values by the time steps. This is the 1000 time step, 2000, 3000, 4000, 5000, and there is a decent decrease in the loss. So it means that we are doing something right. Now, since the training is complete, let's actually go to the fun part, which is taking results, okay, the inferencing part. So we can start it by giving a prompt. Okay, so this prompt is what I choose. Who is Napoleon Bonaparte? I want the model to explain to me who is this person. So for that, we create a pipeline for text generation. We can do it by pipe equals to pipeline, and we give the name of the task, which is task generation. We give the model, we give the tokenizer, we give the maximum new tokens, and this is actually where it gets important to configure correctly. So we will have parameters such as max new tokens, number of beams, early stopping, no repeat engram size. What these are is that they are decoding strategies, okay, and they actually can greatly impact the results you get from your model. It is very important to configure them correctly. In this case, I configured them like this, But what I suggest you to do is experiment with different values and check this blog out. Okay, this is blog from Huggingface. Again, this is how to generate text using different decoding methods for language generation with transformers. It explained the greedy search, beam search, and some sampling methods. I think this is a very crucial step. It can be the difference between a good result and a nonsense output. For this case, I chose like this. For me, it works fine. Like I said, I won't explain what they do. I suggest you check that blog out. Now we have our pipeline ready. The next step is we will get our prompt together. So first step is we have the system prompt. Like we mentioned during preparing the data, this is the general prompt that we give to the model. This just says, in our case, below is an instruction that blah blah blah. After that, we have new line here, and we start giving our instruction. We started with 3 hashtags since our data format that we did the training is formatted in that way. We started with that. We put a new line and we put our prompt in it. So our instruction is ready. The next thing we expect from the model is to generate a response. We give the response with 3 hashtags so the model knows that it should start generating the response. And that will be our whole prompt. We give our prompt to the pipeline with result equals to pipe, and our results will be result. In the end, we print our result 0 with the generated text field. Okay. If you want to generate multiple outputs, there's an option for that in the pipeline. You can choose how many outputs you want to generate. And let's run the cell. So let's look at the results. The response is where the model started to generate. It started with name, in this case Napoleon Bonaparte, and was a French military and political leader who is best known for his role in French Revolution and Napoleonic Wars. Napoleon was born into a wealthy family, and it continues like that. And it is a pretty decent output. Let's try a couple of more things. Now, instead of asking for information, let's ask about the model's opinion or something. For example, what is your favorite color? Okay, that is a classical small talk. Let's try to do a small talk with the model. The same procedure, we define a pipeline with task of text generation, model, tokenizer, max new tokens, number of beams. Like I said, you can choose a different strategy with different parameters, which is crucial. Early stopping, non-repeat n-gram size. After that, we give a prompt to the model, just we did previously. We put the instruction, we insert our prompt, we insert the response, we give the prompt to the pipeline, and we wait for the results. Now our response has been generated. Let's look at it. Instruction, what is your favorite color? That's what we ask to the model. And the response is, I love all colors, but my favorite is blue. It's the color of the sky and ocean. It reminds me peace and tranquility. And I also love purple, etc. And it continues to talk about other colors and some, opinions and things like that. So it is pretty impressive for this too, to ask a model his opinion on something. Next, let's do one more thing, okay, one more generation. So we start the same procedure. We have the prompt, which of the following cities is the capital of Spain, is the question I want to ask. But differently from the previous ones, I give a context. So what it means is that I want the model to choose from one of the given choices. In this case, I want to choose the model from Istanbul, Madrid, New York, and London. Okay, I don't want any other answer. We give that context. And we continue with defining our pipeline. Task is task generation. I use the same argument values, okay? And we continue with the prompt. So there is another small difference here too. It is a slight difference that is easy to overlook. So if we go to the other tasks without context, system prompt was below is an instruction that describes a task. Write a response that appropriately completes the task. However, when we give a context and we want the model to choose from it, we do something slightly different with the system model and system prompt. we say below is an instruction that describes a task. However, we add paired with an input that provides further context. Okay, that's why we refer to context values here. So we want the model to choose from those contexts, and we try to make this too easier to understand for the model with this system prompt. That out of the way, we put our instruction, which is our prompt, which of the following cities is the capital of Spain. After that, we give our input, which is our context. And the rest is the same. We have the response and we closed our prompt. We get the result by feeding our prompt to the pipeline, and we just print our result with the generated text field. Let's run this. Now we have the output. So we have the system prompt, instruction, input, and our response. So the response is Madrid. Madrid is Spain's capital city and the largest city of the country with a population, and it goes like this. This is very impressive considering that we only trained with 10% of the total training data, and we can do small talk, we can give options, and we can just ask for general information. This is something very powerful. Thank you for listening, and congratulations for coming this far. If you enjoyed it, don't forget to like the video, what you want to see next, comment it out, and always subscribe to my channel. Thank you.